In chapter 4, you need to know some of the pattern or some of the method. How are we going to present experimental data or any data regarding to study, any study, how you want to present it so that it can explain much more easily to the audience or to the readers. So one, we have the plot data, get dot plot. The other is we have also scatter diagram, and then we have the box plots, and we have the histogram, and also other than that we also have the team and leaf display. Okay. In the previous test, which is test 2, you were required to draw dot plot and also the frequency distribution histogram. Eh? Frequency distribution and the histogram. So the question that appeared in your test like this. Okay. The following data gives the total farmland area in Malaysia from 2000 to 2020 for the past for the 10 states. Okay, it has the past 10 years data and it's given like this. So the question is to construct a plot dot plot base on this data. So from all of the answer, I found one or two answers which is not doing the dot plot. Okay, from the answer, I saw that the answer is box plot. Eh? Box plot and dot plot is a very different thing. So make sure you don't do mistake in your examination. This is dot plot. You are only putting marks on a horizontal line, whereby the box plot is the other one. Okay, the box plot is the other one with the whiskers. Yeah, this one. Okay, we will come to this. So when you have the answer in the dot plot, that means you only have vertical or no, horizontal line for your axis. So some of you putting as like this, you have this 33, 33, 48, 50, 49, 40, 34, 44, and 129. Some of you put it as a number here. Okay. Even though this data was taken in sequence, in dot plot we are not considering the sequence. We do not need the sequence here. We only want to see how many same value is appeared in all of this data. So from this we can see that we have 33. Okay, and then we have another 33, and then we have 48. We have 30. We have 30 another one. We have 47. We have 40. We have 34. Okay, 34. We have 44, and we have 129. So If we group this data into several groups, we can see that we have how many groups here? 1, 2, 3, 4, 5, 6, 7, 8. Instead of 8 data, 10 data, we have 10 sample here. When we group it, we have 8 groups. So the exist for the dot plot will be only one exist. Okay, the minimum, and then we have the max. From this data, you have 129, and the minimum you have 30. Okay, this is the rough figure here, but we cannot draw the graph as this value. Okay, you can put it, draw it like this. Maybe the minimum you can put it as 0. The maximum you can write it as 130. To how many sections? So you have to plot it based on this uh, horizontal line here. Okay, then you do not need y. Don't put y axis. For this plot, for the dot plot, you only need at the x axis. You don't need the y. We do not have y in dot plot. So remember that, because some of you give the answer as like this. Okay, this one, the value, and then you put value here. So when you put value or you uh, draw y-axis, you are going to have a mistake, because you will get confused on how to draw the plot. So without the y-axis, okay, without the y-axis, you can just draw the line. So you can just draw the line like this, and then if you have the value here, maybe this is 30, 40, 50. Okay, when you have data 30 and 30, you can just put it like this. Okay, one, the first data, and then the second data. This distance doesn't matter. Okay, do not put or draw the plot. Okay, the plot, do not draw your dot on this line. Okay, don't do like this, because it will confuse the reader. You must put it at about. So this figure here also showing one of the example of the dot plot. You can make it in line. You can also make it in like a box. Okay, dot 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 dot, and then we have some more and some more. But The most important thing is that you have the scale. You must put scale at the bottom of the box. That is what we call it as dot plot. And okay, from this slide here, you can see there is a question, example 2 dot plot. This one I would like to ask you to do the dot plot as for your revision or your practice. Okay, uh, this example here, we have a data 42, 47, 47, 50. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 20 data, and then you can categorize it. We have 42, 4.2, 4.7, 4.7, 5.0, and then you have 3.8, 3.6, 3.0, and then you have a 5.1 and 3.1, 3.8, 4.8, and then we have a 4.0, 5.2, 4.3, 2.8, 2.0, 2.8. No, we have 2.8 here. 2.8, 3.3, you don't have it. 4.8 and 5.0. So we can see that 1, 2, 3, 4. We have a 4 value which have the same value here. So the data should be drawn as maybe 4.7. We have 2 dots. Okay. 5.0 we have also 2 dots. 4.8 also have 2 dots. And then you continue with it. Okay. Then you can complete this answer. So another diagram that you need to know how to plot it is the scatter diagram. The scatter diagram, it always comes with two axes, axis 1 and axis 2. So how are we going to define which one going to be the x, which one going to be the y? Okay, don't make mistake with this, because in this question also, in your test, this one, okay, some of you draw it wrongly, okay, whereby I found an answer where he put the y-axis as, I don't know why, 30, and then the maximum is 130, sorry, 130, and then at x-axis, you put it as 1, 2, 3, 4, 5, 6, 7, and so on. So the first one, 33, is plot here. 2, 33, plot here. And the third one, 48, plot right above. And then 4, bottom. And then finally, at the last one, at the 10, you plot it as maximum. Okay? Because it's 1 to 9. This is wrong. Totally wrong. Because dot plot only one exists. Okay, just remember that dot plot one exists in X. Okay, uh, for the scatter diagram, scatter diagram must be X and Y exists. Okay, it is a must. Okay, it must have two exists. So when do we want to put it X as the value, and when can we put it as Y for the value? So actually in experiment or in any data, we have what we call it as parameter. Parameters. Parameters can be divided into two. One is input, one is output. Okay. So the input must be in X, output must be Y. Okay. So in this case, the relation, we want to see the relation between the temperature and the effect. This is what we call it as variable. Okay, in experiment or engineering, we call this data here, this value here is as the variables. This one is for the output. Okay, sometimes we call it as the input for the variables. So we want to see what happened when the temperature change. Okay, when we set the temperature from the smallest value, which is 24.2, and to the upper value, which is 28.6, I think. Okay? 20, no, 30 something. Okay? In this data, we have the value 32, the maximum one, the smallest one is 22.7. So this temperature is not arranged in sequence. Why we do not have this data arranged in sequence? Normally, in experiment or in collecting data, we are avoiding doing experiment in sequence because we do not want to have influence or biased judgment during the measurement. Okay, that's why we do it in sequence, or maybe in some process this temperature is not controllable. Okay, it's not a controllable, but we can measure. Okay, we can measure, but control we cannot. We just take the data for the temperature, and in this case, when the temperature, for example, is 32 degrees, number of this set was 24. Okay, this is the result. So the result must be in y-axis. So when we plot it, just plot it like this, and then we have scattered data. So this is what we call it as the scattered diagram, and how we do it is just as I explained. So in scattered diagram, another question that might be asked is give comment on the graph. Okay, when you are asked to give comment on the graph, you have to state the relation between x and y-axis. Okay, so relation can be seen as the curve. Is it a straight line or is it exponential or it is just a random? Okay, no relation at all. So the curve also, when we say about the curve, we might be we might have the value it increase, it can be decreased, or we can say there is no relation. This one is positive, negative, or no relation. So you can describe it as this. Okay. So in this pattern here, in this question here, without any calculation, again, without any calculation, without any equation used, you might say that we have a positive relation because the data here roughly, okay, roughly we can say that the maximum one and the minimum one here is like this, is here and here, but in average it's like this. When we draw a line, we might have a line like this. Okay, we can say it as positive relation. But in chapter 5, you already learned about the linear regression. Actually, we can calculate this data to get in the equation y equal, if I'm not mistaken, is b plus this. Okay, you can have this equation. So you have the inclination here, then you can say whether it is positive or negative or no relation. So uh, once again, the scatter diagram, we need y and x axis. Y is for the output, and also you have to describe about the relation by stating whether it's positive, negative, or no relation. Okay, that is for the scatter diagram. So the next slide, I already prepared for you one example of the scattered diagram exercise. Okay. Uh, Table 6E6. So I took this question from a book, and okay, okay, we have a data. You might see your slide. You can look on your slides. Okay, the sports network, maybe this is the source of the data taken. It is suspected that the rating Y is related to the average number of yard gained per pass attempt. Okay, and then construct a scatter plot of quarterback rating versus yard per attempt. So the question here is, you have a draw to rating to the attempt. Okay, rating to the attempt. So the attempt here is for the X, the rating is for the Y. Okay, you can draw plot here like this. X, Y, X is attempt, and this one is rating. Okay, so you have two data. Okay, the data is a little bit difficult to plot, but you have to make it anyway. So the minimum is 7.1. Okay, maybe you can put the minimum as 7.0 and the maximum is 8.39. Okay, maybe the maximum here you can put it as 8.5. Okay, don't put it as 8.39. You have to put it as 8.5, or maybe you can use 8.4. You can decide it which one, which are the numbers that is much more easy for you to do. Then you can plot it. It's 7.2, maybe a little bit like this, and then you have the value. The minimum value here is 95, but don't start with 95. Maybe you can start with 90 at the minimum, and then you have 95. So you can plot like this. So the maximum you have 105.5. Maybe the maximum you can put it as 110. So you can plot just easily like the previous example. And then another question might be asked when you're plotting the data in X and Y axis in scatter diagram, it will ask the simple correlation coefficients. The simple coefficient correlation, okay, whether this plotting is, even though this plot is about scatter diagram, which is explained, okay, which is explained in chapter 4. Sometimes mixed question appear in your test. So after you plot the data, you have to explain what is the relation. The relation, the equation of correlation coefficient is in chapter 5, I think. Then you can calculate the simple correlation coefficient using this formula. Okay. In your slide, I think I forgot to put the formula, but you can refer to chapter 5, I think, if I'm not mistaken. But I've given here, you can write it down. Rxy is referred to correlation coefficients. Okay, coefficient correlation is Rxy. You have to accumulate the result of y value times x value minus mean x. Okay, and then you have to calculate the y minus y mean square times the accumulation of x minus x mean square. Okay, all of it you have square root it, and then you can calculate. So the simple correlation relation, you might have the data from 0 to I think 1. If I'm not mistaken, you can refer it back. Whereby if it is 0, it is no strong relation. If 0.5 and above, it's strong relation. I think like that. You can see at the slide coefficient correlation. Uh, so So that was the scattered diagram plotting method. Okay, and then another question is about the box plot. So it doesn't appear in chapter in test 2. Okay, it might appear in your final exam. How to draw the box plot. Before you draw the box plot, in your test 2, actually you have the dot plot. Okay, the dot plot, and then in your examination you will ask about this one. Okay, do these data contain an outliers? Okay, outliers, justify your answer. So you have a value totally different here, 129. From this chapter, when we only talk about the dot plot, we can only say that there is outliers because the value is totally different from the others. We can just say the reason as like that. But if you are asked and the question asks you to draw the box plot, then you have to calculate something so that you can say whether it is an outliers or not. Okay, so box plot, this is the example of the question of the box plot. I give you one example in this slide here, and the number is quite small. Okay, this is the number 88.5 and so on. We have 1, 2, 3, 4, 5, 6, 7, 8 column. 1, 2, 3, 4, 5, 12 lines. So from this data, it is easy for you because you are going to have a test in online class. You can arrange it in Excel, okay, in Excel file. So you can rearrange it, and when you arrange it, you will have a number in sequence, and then you can easily define the median. Okay, you can easily define the median, and you can also easily define the quartile 1 and quartile 3. Okay, so in solving the box plot, make sure you calculate or get all of this value here. This one you have to mention it in the first line of your answer. If you want to start the answer, then the first one is you have the minimum value, maximum, and then you have the quartile 1, quartile 3, and the median. Get the value first. When you have the value, then you can draw the box plot. Okay, you have the mean, you have the max, and then you have the median, you have the Q1, Q3. Okay, that is how we draw or how we answer the box plot. So this example here, I already give you the answer, and the answer and this slide also I gave you in the class at the last pages, I think. the last pages of the slide. I already gave you this example, and wherever read it, maybe you can find it and you can understand how to get the median quartile 1, quartile 2, quartile 3, because quartile 2 is the median. Okay, in my class I define it as like that. Maybe in other class they are defining as quartile 1 and quartile 2 and median, but in my class we have mean, minimum, Q1, median, Q3, and MX. Okay, this median I define it as Q2. Okay, so when you arrange all of the data using Excel without any mistyping, so you can have the data along with 82. When it's 82, so the median must be in between 41 and 42. Okay, 41 and 42, the data is 90.4 and 90.4. The median between 90.4 is also 90.4. This is the median value. Okay, like this, like as this one. The Q1, you have to look at the, because the quartile of 42, 82 is 20.5. Okay, 20 to 21 data. So data 21, 20 is 88.8, 88.5. Okay, and data 21 is 88.6. When you make it in average, you have 88.575. This is for Q1. So same data 62 and 63, you calculate it, you will have 92.2. Now we have one value here, one value here, one value here. Okay, that is our value. Three value, we already get the three value, and then we can plot it in a box. First, draw the box first. Okay, Q1 is 20, no, 88, and the Q3 is 92.2, and the median is 90.4. So this is the box. How about the whiskers? Okay, whiskers. So to draw the whiskers, this example here I took it from the books. Actually, when we draw the whiskers, there is a way. When you want to define whether in this answer question here, do we have the outliers? Okay, what about the outliers? Do we have the outliers? When we talk about the outliers, so actually in your slide, chapter 4, okay, this one. Okay, please look at slides. You can look to your slide after this. We can see here that between the Q1 and Q3, we have value Q1 and Q3, we call it as IQR. Okay, IQR 1 and 3, we call it as IQR. Okay, then we go back to our question here. This is the IQR. So IQR is equal to the difference between the Q1 and Q3 and Q1. Okay, 92.2 minus 88.575. You can calculate it. Maybe you can have 5 here. You have 2, 6. I think we have 1. We have 3. I think. No, I'm not mistaken. This is the answer. 92.2 minus 88.575. We have yeah 3.6. So the maximum here, this value here, okay, this value here, it should be 92.2, okay, plus 3.625 times 1.5. So you can refer to this value, okay, the value here. The lowest viscous is a line from the first quartile to the smallest data point within 1.5 interquartile range. Okay. Actually, this figure here, we have a little mistake here. Viscous extends to smallest data point within 1.5 interquartile range from first quartile. First quartile, interquartile. Okay, this value here, you times 1.5, you will have the viscous length. Okay, this also you have the viscous length. So then from that, so from sorry, where is my, okay, so we have here, we have the value here, which is Q3 plus IQR times 1.5. Okay, this is for the value here. So for this value here is Q1 minus IQR times 1.5. This is the value bottom here. So any data which is not in between of these two plot here, two point here, we consider it as outliers. We can have the plus outliers, we can have the minus outliers. Okay, so the box plots, okay, in the chapter also you have, I've given you another example of the to draw the box plots, and then you can draw the box plots, calculate the simple mean, simple variance, simple distribution. This item here, most of you, I can say 100% got it right in your answer. Okay, you have right answer over here, but then this only conceal only give you marks. I think not more than uh, 7 now. Okay, question. Okay, the first question answer the answer is 6 marks, 4 marks, but draw the good. Calculate the median variance and deviation. You have 6 marks, but to calculate the histogram, the answer is quite different. Small of sorry. Just to calculate the mean variance and deviation, it won't contribute big mark in your exam. The next question will give you the most marks contributions. So in your test 2, you only have the uh, dot plot, which is the mark is very small, and then you have to construct a histogram. So if in case that you are asked to construct a dot plot, the distribution marks it might is the total is 20. So here the marks here I think it's not more than 10, and this one is the most is will be larger than 10 marks. Okay, so in this question you have to answer the least value, the maximum value, q1, q3, and q median, and then you have to calculate the IQR, which is equal to q3 minus q1. Okay, and then you have the maximum viscous, which is q3 plus 1.5 times IQR, and then you have the minimum viscous, which is q1 minus uh, sorry q1 minus 1.5 times IQR. Okay, and then after this you also have to define any outliers. Okay, so every of you managed to calculate the simple mean, simple variance, simple standard deviation. Uh, but I think to construct the box plot, you have to do exercise for your final exam. So this one, I would like to ask you to complete the answers. And okay, frequency and distribution histogram. You have a question in frequency distribution histogram. Okay, then this is the question in your. You have the data 7.5, 6.1, and so on. Okay, you have to construct histogram. Okay, histogram and also the distributions. So in the today's slide, I also include one example of the histogram distribution solving method. So in histogram, the first step, you must first solve or get the value of K, then W, U, and L. Okay, this is for upper limit and also for the lower limit, and you have to prepare the table. So you are using a computer in your test in final exam. From all of the data, retype it, and then you can select the maximum and the minimum value. Okay, maximum and the minimum value. From the maximum, if for this data the maximum is 100.3, we have the minimum 83.4. Then you have to calculate. Okay, you have to calculate the value of W. Okay, W and K. So in the your exam, in your test two, so the question here is, by using 8 classes, construct a histogram of time consumed. It already mentioned here 8 classes. I could not understand why some of you do not make it in 8 classes. Some of you only put 7 classes. Okay, already mentioned 8 classes. You have to draw it in 8 classes. Okay, so your final histogram should be in 8 classes. Okay, you have, if you have like this, maybe another one, and then another one, and then another one, and then another one, and another one, and 1, 2, 3, 4, 5, 6, 7. So even though the last one the value is 0, you have to put scale. Okay, mentioning or showing that you have 8 classes. You have to make sure that your figure have 8 classes. So this is a question. The question was a question where the number of classes is defined by the examiner. Okay, by the examiner. But actually, the number of classes you have to figure it out by calculation. So the calculation of classes, you can take it from the square root of the sample. Okay, we have, for this example, we have the value is 9.06. We can take it as 9, we can take it as 10. Don't take it as 8.5. There is no classes in a decimal point. So in this case, if the value is like this, 9.06, I recommended you to take the small value. Okay, small value. But if the value here is maybe 9.6, then you can take it as 10 and the classes. Okay, now uh, now we have two possibility. If it is 9 classes or if it is 10 classes. Okay, in this answer here, I already give you two possibility of answer. One, if you put it take k as 10. One is if you take k as 9. After you got the k, you have to calculate the w. Okay, the w is the width. Okay, this one is the width of each classes. Okay, if you have k is 10, then you can calculate your w. In this case, the w is when it's 10, you divide it by 10, you can have 1.69. If the k is 9, when you can have 1.87. Okay, so then you can define the lowest value and the uppest value. So this is the formula for you to calculate the uppest and the lowest, and then you can assume this one. If you don't want to take it 1.69 because it's difficult to calculate, okay, you can make it 1.7. This one you can make it 1.9. Okay, it's okay like that. But in this example here, the lowest and the minimum is kW minus R. R is the range between the maximum and the minimum, and K is 10 divided by 2, and we have minimum is 83.4, and then we have the maximum and the lowest one, upper and the lower. So here, then we have the results of 1 and 10. Okay, 1, 10 classes and also 9 classes. The result will be different. Okay, will be different. In this case, the W was taken as 2. Okay, the W here was taken as 2. Okay, when you assume W as 2, because it's much more easier for us to calculate it, okay, and easier for us to draw the histogram, then we have data like this. So in this data, we have the minimum and to the next point. So the first one is 82.85 for the example, and then the maximum of the first class is 84.85. So this value must equal to the next minimum value of the second class. Some of you have gave me the answer whereby the maximum of the previous class is different to the minimum of the second class. Okay, you need to have it like this, because when you plot, you don't want to have gap between classes. You do not want any gap between classes. Okay, it have to be continued. Okay, the border between two classes is the same value. Okay, they are having the same value. So make sure that this value here will come to this one, this value here will come to this one, and the next value will come to the next one, like that. So make sure don't do mistake on the classes here. And then you have calculated, and then you can have the distribution. This is what we call it as frequency distribution. The data, the graph here, we call it as the histogram. Okay, and then when you draw the graph, make sure you have the what is the name of existing x-axis, what is the name of the y-axis. So when you plot, you have like this. Another question might be asked in this plotting method is, what is your comment? Give comment on the distribution. When you are asked to give comment on this distribution, that means you have to state what is the relation between x and y. Okay, in this method, you can say whether it's negative skew, positive skew, or symmetric. This is the positive, negative, whereby the maximum is at the right side. This is the positive skew, okay, and this is the symmetric. So you have to mention it like that. But before you are able to make any relation, it is proper for you to add another calculation. Okay, the next calculation is relative frequency, cumulative relative frequency. Okay, the maximum value of this one is 1. This is also 1. So the total accumulation of this one, okay, is equal to 1. Cumulative relative frequency. So when you draw a data, you can have like this. So then you can say what is the relation between those x-axis and y-axis. So in this frequency distribution histogram also, I already give you one frequency example of questions, and then the next one is about the steam and leaf diagram. Steam and leaf diagram is quite equal to the histogram, but you can say it seems equal, seems the same, but actually it's totally different things, whereby the method of showing the presenting the data is quite different, whereby you have to like you need to have a table like this, okay, and you can distribute it to the upper lower of each categories. But the method of calculating the median, the quartile is quite the same. Okay, median quartile is quite the same with the previous subject that I already explained to you, which is the frequency distribution and the histogram. But the method of presenting the table in the table is quite different. Okay, we have in this chapter we have the leaf and we have the stem. Quite blurred here, the value, but then you have to arrange the data like this. 8L is 8 lower, 8U is 8 upper, whereby 8 lower represent the value of 80. That means your data is 0.4. We have 84.3. 84.3. So this is the data which makes this leaf look like this. For 82, 8 upper is this one. You can 85.3 with this one, 88.3. So you arrange like this. Okay. Another example is 10 lower is 10 lower. It represents data of 100. Okay. If 8 if the leaf is 0.20, that means 100.3. Okay, and this one is 96.1, 96.5, 98.8. So quite confusing. This method is quite confusing. You can have a many possibility of uh, having mistake when you arrange it. Okay, but the category here you can define it yourself. You have the lower and the upper. Okay, you don't have to calculate the mean by calculating maybe the sample of n. Okay, square root of n. You don't need this. You just have to arrange like this. Now calculation. And then finally you can calculate the frequency. We have 3 times, 31 times, 44 times, 3 times, 1 times, 7 times. You don't have to calculate the frequency ratio. Okay, this is for the steam and leaf. So for the steam and leaf also you have one exercise here for steam and leaf. Uh, so I think uh, from the last 2 days, okay, I already explained how to answer question 2 and also question 1b. So question 1a is just about the theory. You can read the books. I think you can answer it. Mean square of IQ test is less than 95. So this one is, then you have it. -95, and then you have the okay. This one is equal, okay. And the answer for this question, this I show you a little bit about this. So this is the answer for the question. If you I cannot give you this file. If you want to see, you have the file. You just write it down. What is the answer for this question? Reject HO 95 when the mean square is HO 95. Type 2 error is do not reject HO when the mean score is actually less than 95. So the question here, when you see this IQ less than 95, this one is the soybean, SB equal to 3 to 5. Okay. The type 1 error, reject HO when the mean square is actually 95. So this one, we have a possibility like this, not equal, not equal to 3 to 5. So the answer is you have to reject the HO, the null hypothesis, when the mean square is actually 95. Okay, this one is regard as the HO when it's a type 1. Okay, when it's type 2, do not reject HO when the mean square is actually less than 95. So this is for the H1, and this one Reject HO when the mean is actual 3 to 5. Okay. This one is for the HO and H1. And do not reject HO when the mean square is actually different from sorry, this is reject HO when the mean score is actually different. And do not reject HO. This one is for the HO, this is H1. Reject HO when the mean is actually, yeah, sorry, this one is mm, reject HO when the mean score is actually 95. And do not reject HO when the score is actually 95. So like this. So this is the statement in the question. This is also the statement in the question. Okay, it's quite different from the normal activities because this is in the state uh, sentence. We have to define it to explain it when it is a type 1 and when it is type 2. So when it type 1, okay, when it is type 1, the statement here is IQ test is less than 95. Okay, IQ test is less than 95. We have to reject the HO. Okay, we have to reject this statement here when it's not as the stated here. Okay, we have to reject HO when the score is not as in this statement. Okay, the statement say that it is less than 95. Okay, for type 1 error is the possibility that we reject the uh, statement. Okay, the statement when this statement we assume is as a null hypothesis. Okay, the statement said that it must be equal to 95, but when we found out that the statement is the score is actually 95, we have to reject the HO. Okay, we have to reject the HO when it's actually 95. Okay, so for the type 2 error, okay, the type 2 error, we do not reject the HO. Okay, we do not reject the HO when the mean square is actually less than 95. So type 2 is opposite to type 1, and for the type 1, for the second is the statement here is the drink can is equal to 3 to 5. Okay, statement. The statement said that it's equal to 3 to 5. Type 1 error, this is the error where we have the possibility of rejecting the statement. The statement says that it is equal to 9 to 5. So for type 1 error, we we might reject the HO when the actual is not as the statement. Okay, the actual is not as the statement, we reject the HO. So reject HO when the mean is actual 95. Okay, So I think that's all for today. Uh, so I would like you to do the exercise from all of the questions in the slide I given you today. Ulang kaji the whole, you have the second example 2 for each scatter diagram example 2, box plot example 2, frequency distributions example 2, and steam and leaf display example 2. So please do it, and I will give you the Google form. You have to submit it before the next class. So discuss among your friends to have the best answers. Following the example in these slides, okay, do it as detailed as you can, and I will ask you to submit it before the next class. I will release a Google form for you to submit this uh, exercise. So make sure you read it, because I'm very confident you are not reading my slides. You don't understand my slides. That's why you have a mistake in the steam leaf, no, the histogram. How to write the histogram? Some of you just write down the histogram without calculating the value of the most important value, which is you firstly need to calculate when you are given the B number, you have to calculate the range, and you have to calculate the lowers and uppers. So some of you just uh, writing or drawing the histogram without any calculation. You have to do calculation at least one or two equations. Okay, so please remember to solve this problem according or just as what I show you in this slide. You need to calculate the N, K, W, and so on as detailed as possible, because all of these H lines contributes marks to your answers. From the method of answering the test 2, uh, it's hard for me to give you marks, and I think all of you have given marks, extra marks, whereby I just assume that you understand. But actually, when I want to stick to the uh, answering scheme, there is a possibility that you have much more marks, because you fail to write down the detail how you can get the answer in your examination or in your test. Many of you just jump to the answer without calculations. Okay, so please be aware, in the next final exam, make sure all the method calculation detail is provided in your answer, so that you can have the maximum marks in your final exam. So that's all for today.